Hello, everyone. Happy Friday. I hope everyone has had an amazing week and has some fun plans for the weekend. It's going to be Halloween tomorrow, so people are going to be out trick-or-treating. People are going to be dressed up in costumes. My costume is my bedhead. I wake up every morning and I'm terrified of what I see in the mirror, but this is why hair gel and a comb exists. I want to bring a nice welcome to everyone that we have with us today. Whoa, lots of people we have today. Meli, Iris, Jorge, Emelida, Adriana, Veronica, Chela, Anna, Berta, Kira, well, that one. uh, Eddie, Marta, Andrew, Yesenia, my mother, Mayra, hello everyone, Zamanda, hopefully everyone is doing well, Pescadito, Sonia, Jacqueline, Irene, my apologies, Javier, hope everyone is doing well. Thank you for being here with us today. I have maybe a little off-topic topic for today's class, but I want to share it with you because it's something that many of you are familiar with because you've heard the word a lot, but many of you may not know exactly what it means or how much of it is just marketing fluff. So today I want to share with you all the basics of machine learning, what it is, what it looks like, but most importantly, why you should care. Because again, many companies will say to you, oh, we use machine learning and AI. What does that actually mean and why does it matter to you? That's what I want to explain through today's class. So let us get started with this presentation. So as I said before, the topic of today's class is going to be machine learning. So we need to start with the basics, which is, what is machine learning? The simplest answer to this very complicated question is that it's a robot. We create a robot that we can give a bunch of information or a bunch of questions and have it give us an answer as its response. So you push in a bunch of things and it gives you an answer. If many of you have seen Hitchhiker's Guide to the Galaxy, the answer to life, the universe, and everything, this very complicated question goes into a machine, beep, boop, 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 and it gives you the answer 42. So that is, in essence, what a machine learning network is. Thank you all for joining us today now. So it can be thought of as a math formula, or in fancy terms, an algorithm. So often you'll hear machine learning referred to as a machine learning algorithm, where it takes a bunch of different inputs or ingredients, pushes them all into a machine, and it spits out an answer. And these answers are a prediction, or what the machine thinks the answer is. I want to put emphasis on the word think, because machine learning answers are not always correct. And that is the most important. If you take one thing away from today's presentation, I want you to take away that. Machine learning is not perfect. The answers it gives you are not always correct. And there's no substitute for doing your own thinking and your own research. So again, if you take away anything, that is the most important thing. Machine learning is not some magic box that will always give you the correct answer. And we'll talk about why in a few moments. So now we know what this magical machine is. How does it work? Well, let's use an analogy. Let's use an example. Think about it like a classroom in school. You have a teacher and you have students. And the teacher goes home and says, I want to give a test on the types of trees. So the teacher goes home and writes 100 questions. Now, it's not going to be a 100 question test. So Why write 100 questions? Well, the teacher will write 100 questions with 100 answers, and this is what the students will be graded on. So the teacher will give about 80%, so 80 questions will be a study guide. So the teacher will say, here is 80 questions and the correct answers. Go home, study this stuff, learn so that you can guess the correct answer. So then the students come in and take the test. And the students' grade is the number of questions that they got right. So again, if there was 100 questions, 80 questions are the study guide, 20 questions are the test. And then the teacher tells the students, okay, you got 18 of 20 correct. Okay, you got 19 of 20 correct. Okay, you got 4 of 20 correct. And the students learn what questions they got wrong so that they can go back and study what they got wrong and then take the test again. And it's this constant process of study, test, figure out what you did wrong, study again, test again, figure out what you got wrong this time, study, test, rinse, and repeat. And the result of this is going to be everyone will get smarter. Everyone will learn how to get more and more questions correct. But there's going to be one student, there's going to be one star student that gets them correct more often than other people, finishes the test faster. There's just one person that is just brilliant. And that is the algorithm. That star student is what we want in machine learning. We create a big classroom. We have hundreds, if not thousands of students that take this test over and over and over because we're looking for that one star student that we then say, okay, you're the one, you are the one that gives the correct answer the most times and gets the answers the fastest. So that is what machine learning does. It's a process of study, test, learn, study, test, learn, until we finally get one that we're happy with. And that's what we take as our algorithm. So there's two types of machine learning that I need to talk about. The first one is unsupervised learning. This is when the students are given an open-ended question. There is no correct answer, or rather, you're not given the correct answer. So we'll come back to this one. This one's a little bit more complicated. The one that I want to focus on first is called supervised learning. Supervised learning is when we give the machine a bunch of different questions, but we also give them the correct answers. So we give them the questions and also the answer key to study from. So they're not just learning what the questions are, but they know what the answer is as well. So they can try and figure out, well, if I get 2 plus 2 equals 4, if I get a question 2 plus something equals 4, I know the answer. I've seen that before. So the machine will take some of these questions and answers and study them. And then it will test itself on the leftover questions and grade itself based on how many of these questions it got right and wrong. And the machine tries to get the highest number of correct answers it can. It tries to be the best it can possibly be. So this is what I just talked about before. And the advantage of this is it's very easy to train it to get the answers correct. But the risk of it is that we run into two problems called overfitting and bias. These are two machine learning terms that I want to go into a bit more detail about because they're very, very important. First off, a machine learning system is only as good as the information we give it. Because if I teach a machine how to do addition and subtraction, that doesn't mean it's going to know how to do multiplication. It's never seen that before. So supervised algorithms may have a hard time with questions it's never seen. Or in other terms, I may have been this student. Hopefully I've gotten better, but I used to be a very, very good test taker. I was very, very good at going home and studying to take the test, and going in and taking the test I was great at. But if you gave me a question that wasn't part of the test, I would have no clue how to answer it. So the same thing can happen with machine learning, where some computers or some systems will be very good at guessing the correct answer, but only for the questions that it's seen before. It's not good when you give it a new question. So this is what's called overfitting. Overfitting is when you have a machine learning system that can only guess the answers for questions that it's seen before. So you could teach it what 2 plus 2 is, but the minute it sees 2 plus 3, it has no idea what to do. It can't figure it out because it's never seen that question. All it knows how to do is answer 2 plus 2 equals 4. So then the other is called bias, where we can give it the study guide to study in a certain way and to get certain answers. Such as if I asked a computer, what is your favorite flavor of ice cream? Vanilla or chocolate? That's great. It can answer that question. My favorite is vanilla or my favorite is chocolate. But what about strawberry? What about pistachio? Because I only gave it vanilla and chocolate, it only knows to guess vanilla or chocolate. It doesn't know that there are other options available. So that is what's called bias. Because I taught it what to do, it doesn't think like a robot, or it doesn't think like itself. It thinks like me, which is kind of crazy because there's already one of me. That's enough. We don't need more than one of me. So we want to have a machine that can think on its own. It doesn't think like its creators. So a good robot or a good machine learning algorithm is the one that can answer questions that it's never seen before and has little to no bias based on the information or based on what information we trained it on. So let's do this together. Let us make a supervised machine learning network. And this is a real example that we could do if we had the real data for it. But I want to say this before I go into it. What you're going to see is not what is actually, like, this is not based on real data. I didn't go out and collect or sample a bunch of people and ask them what their favorite ice cream was. This is just me using an example. So please don't run and tell your mom, hey, I bet I can guess what your favorite flavor of ice cream is. Jonathan's told me it was this. I didn't. Sorry. So let's talk about this. We want to answer the question, what is your favorite type of ice cream? So again, we need to create the study guide. So for the study guide, we have what the question is. The question is, what is the person? Who are we trying to guess what their favorite type of ice cream is? So we want to ask them a few things. First, how old are you? Are you a male or a female? Do you have any allergies? Maybe do you have an allergy to peanuts? Because if you have an allergy to peanuts, you may not like peanut, or rather, you may not like pistachio flavored ice cream. Or if you're lactose intolerant, if you can't eat dairy, you may not like you may not like chocolate. Or where are you from? Certain types of ice cream are popular in certain areas or certain regions of the world. So where you are may have an effect on what type of ice cream is your favorite. And what are we trying to get from this? We stuff all of this information into a machine, and the answer that we want is one of the following. We want it to tell us your favorite flavor is chocolate, your favorite flavor is vanilla, or your favorite flavor is strawberry. So I stuff all of this into a machine. What could this look like? What could this thought process or this decision look like? How do we go from how old you are, if you're male or female, if you have any allergies, and where you're from, how do we figure out what is probably your favorite flavor of ice cream? Well, this is a type of machine learning question called classification. And to figure out this, we create what's called a flowchart, or in fancier terms, a decision tree. So here's what that could look like. Now, again, this is not based on any information. This is not the end-all be-all. This is not how you figure out someone's favorite flavor of ice cream. This is just an example. But this is what a real machine learning network could do. It would take the information such as how old you are, where you're from, your allergies, and if you're male or female, put it into a machine, and then it will go through a decision process. It will say yes or no's to all of these different questions. So the first question may be, are you male or are you female? If you're a male, it would then go this left way. Then it will ask you, do you have an allergy to dairy? So then it would be yes or no. If you don't have an allergy to dairy and you're a male, this machine will think that your favorite flavor is chocolate. If you are a male and you have a dairy allergy, then the next thing it would ask you is, are you from California? If you answered yes, you're from California, and you have a dairy allergy and you're a male, it will then say your favorite flavor is strawberry. If you're not from California, but you have a dairy allergy and you're a male, it would say your favorite flavor is vanilla. The same thing on the female side, where now it doesn't ask about dairy allergy. Instead, this machine is going to ask you about your age. It will ask you, are you older than 35? If you're older than 35 and a female, this machine is going to guess your favorite flavor is strawberry. If you're a female and you're not older than 35, it's then going to ask you, are you from Mexico? If you are from Mexico and you're not older than 35 and a female, it's going to say that your favorite flavor is chocolate. If you're not from Mexico, but you're not older than 35 and you're a female, it's going to guess vanilla. So all of this is using those 4 pieces of information we gave it before in different ways. Sometimes it's asking male or female, and then other times it's asking yes or no. Other times, like the older than 35, it's going to choose a number. It's going to choose one of these options and then say split based on that. Split based on the age of 35 or older. Or then another one may, and this is all one student, by the way. This is all a single person's thinking. Another person may think the exact same, but it has, instead of older than 35, it may have older than 50. So these are all different ways of thinking, but again, it all goes down to the same thing of what will this machine give you? What is the answer that it gives? And this is a style of network that is a real thing. And I'll share a story in one moment, but this is called classification. It uses a bunch of information to guess something. So it may say it's a dog or it's a cat. It doesn't say, I think the answer is 32. It says, no, that's a dog, or no, that's a cat. So I've actually done this for work. I was responsible for sending out emails, and I wanted to find out who had the highest chances of opening my email. So I created a system like this. I gave it who I was sending it to, if they opened the email or not, and how long the email was in their inbox. And all of this was supposed to find out Would they click on the link or would they not click on the link? So I gave it real data. I gave it a bunch of real people's information that, of course, not like actual information, just like that information I was saying before for the inputs. And I would tell it, this person opened, this person didn't. This person opened, this person didn't. And it predicted, it gave me a flowchart like this of exactly who clicked on the link, who didn't, but what those people looked like. So what I'm showing you right now is a real type of machine learning called classification and regression trees, or CART for short. Where this example of ice cream flavors is a decision tree, because if we see, kind of looks like an upside down branches of a tree, or you can think of roots if that's easier for you. But it uses yes or no questions to try and guess what the correct answer is. And it can be used to guess between a few options, which is classification, such as, is it a dog? Is it a cat? Is your favorite flavor of ice cream chocolate, vanilla, or strawberry? Or it can guess a number or a probability. So it could say, I predict that you're going to get an 85 on this test. Or I am 85% sure that it's a cat. This is called regression. And both of these are the most common type of machine learning because it can be trained really, really quickly. It can be used for a lot of data, but most importantly, it's human. It is something that we can look at and very easily see how it thinks. And that's my favorite part about these classification trees, is I can then take this robot brain almost and try it myself, where I take someone's information and I say, okay, they're 36, they're female, they're not from Mexico, so vanilla. So I can use that flowchart, that tree, for my own use, but it's very human understandable. Everyone with me? Everyone's all good? Because now we're going to get to the world of not so human intelligible, but the reason why it's called machine learning, not human learning. Now we get into unsupervised machine learning, where this isn't like supervised learning, which is a test where we have questions and answers. Unsupervised networks don't get an answer key. They just get a question. And they're graded based on how well they can complete that task. And the network that we choose, or the best kind of system, is the one that gets the highest score. And score is a loose term here, because remember, it's not right or wrong, it's just how much. So a great example that I can give is running a 100-meter dash. So sprint. I want to find the fastest way to sprint 100 meters. The lower the time, so the less time it takes me to run that 100 meters, the better. I may try a bunch of different things. I may try a really long jump almost, where I'm not stepping a lot, I'm taking really long strides and see how far I can get. That may give me a time of 15 seconds. Then I may try a way where I'm just running like super fast. My legs are running a lot, but I'm not going as far with each step. That may give me 12 seconds. Or there's somewhere in between that having the right space in your step and the right speed of moving your feet is going to give you the fastest time. And because of this, because it is open-ended, it's very easy to avoid a bias because we're not telling it what we think the answer is. We're not telling it the fastest way to run 100 meters is this. We just say, go figure it out. And it does. But because we're just sending it out there and letting it kind of fly on its own, training can take a long time. It takes a lot more time for it to get the best answer because it needs to try all of the other options first. It needs to fail 500,000 times before it finally succeeds once. And the other thing is it can hit a dead end. Think about it like this. I want to take a ball and I'm on a mini golf course. So there's a bunch of different dips and turns, and I want to find the lowest point on that golf course. So I take the ball and I drop it and it rolls. Eventually, it's going to roll to a low point and then stop there. So now it says, ta-da, I found the lowest point. But it only found the lowest point that it rolled to. If I maybe started on another part of the putting green or on the golf course, it's going to roll down to another point that may be even lower than that first one. So it's all about not hitting a dead end, because dead ends do exist, and the machine doesn't know that it's in a dead end. It's just going to reach the end and say, hey, I did it. I got to the end. But that's not the right end. That's just a dead end. But the machine doesn't know that. And it's very hard for us to know that as well. So the way that they get around this is sometimes the network will have what's called a mutation. Or it's just a random thing that we kind of just shove it a little bit. So it falls over, but then it figures out a new way to work. Because it learns what it's like to be off balance. It figures out how to correct for it. Where now, yes, I'm still tilted sideways, but you're tilted with me. So everything looks normal. The same thing will happen for machine learning. So let's talk about some examples. Let's talk about where you may see unsupervised machine learning out in the wild. When you go shopping, it gives you suggested products. It tells you things you may like. Users that looked at this product also bought this. All of this is machine learning. There wasn't somebody that said, oh, Jonathan Staub will buy this product and then this product. No, they don't know that. All they know is, okay, this other person that kind of looks like Jonathan and thinks like Jonathan and talks like Jonathan looked at this product. Let me suggest it to Jonathan. And then they'll watch. They'll sit there seeing if I click on it. Oh, he clicked on it. And then they write down and they learn from it. So another example is YouTube. When you're on YouTube, look on the right-hand side right now of this video. There's going to be some videos that may be from me, maybe from others, but all of those videos are there for a reason. They are there because someone like you was also watching this video and was given that video as a suggestion, and they clicked on it. So YouTube is going to try and find videos that you would want to watch. So when you get bored of listening to me talk, you go and watch that video after. And then after you click on a video, they go back to the notebook and they write that down for the next time someone comes. Your assistants on your phone, Google Assistant, Siri, and Cortana, they are all also examples of unsupervised machine learning because they don't know what you mean when you ask them a question. They have to figure it out. And they may not be 100% confident in their answer, but they're going to give you an answer regardless. Same thing with autocorrect. Autocorrect, you may type in some random thing because your thumb was on the wrong spot. And it's autocorrect's job to try and figure out what you meant to say. Maybe it's based on what letters were around the letter that you pressed, or it uses the rest of the sentence to try and figure out what word you were going to use. So they'll use different things to try and guess what you were going for. Same thing with the spam filter in your email. It will know what other spam looks like, or what users report as spam, and then learn from that to be able to see the next time it sees a piece of spam, oh, that should go in the spam folder. So all of this is much more complicated, but let me see if I can try and bring it down to a very fun and easy to understand way. Because all of these types of systems are all types of what is called a neural network. This is where we get into the world of AI, artificial intelligence, because it is a system that we give it information. So basically, we throw a bunch of stuff behind a curtain. Magic happens behind the curtain. We don't get to see what that is. And then it sticks out an answer, and we get that answer. So that is what machine learning neural networks are, where it's a more complicated type of network. But just like what we looked at before, our decision trees, it uses many inputs, a lot of different things go into it to get the output. But instead of just a flowchart, a neural network creates a complicated system of points, or what is called nodes, in a hidden layer. So on the right here, if we look, these green dots are the information that we give it. And then these blue dots are like a jury. Each one of these blue dots is given some information. Some, like the top dot, is only given one piece of information, whereas the two in the middle get all of the information. And then each of them has their own way of thinking, their own bias, that then will give us an answer. And the answer from each one of these nodes will always be a number between -1 and 1 in the case of if you say strongly agree or strongly disagree or neutral. So strongly disagree is -1, neutral is 0, 1 is strongly agree, and 0 and 1, which can be yes and no. Each one of these nodes, each one of these blue dots, takes the combinations of inputs and then gives you their answer. So then you, which is the purple, can take all of the jury's thoughts and give your conclusion. I asked Juan, Felicia, Kike, and Rodrigo what they thought. I took all of their answers and then here's mine. And that's what this does. It takes all of the different combinations of inputs, takes their answers, and then I get to decide what the answer is. The reason it is a neural network, and all neural networks will have to have at least one hidden layer, this one blue line of things right here. Some will have more, but you can't have less than one. The last thing is the reason that we use neural networks is sometimes you can't just answer something yes or no. Maybe is a pretty good answer too, because maybe isn't just no, it's not just yes. So we want our thinking to be able to answer, well, maybe, or I'm 95% confident that it's yes. So now we've talked about what a neural network is. Let's talk about now how it learns. How do we create one of these? So the first thing we do is we give it information. We tell it, I have these different things that I'm putting in. And we choose the amount of people we want on the jury, or how many hidden steps, or how many hidden dots do we want. We also get a choice of how many layers to have. You can have one layer of blue dots, or you can have another layer of blue dots. Where, think about it like this. The first layer is for people that only get to see the inputs. They get the raw information and they get to say, I think maybe, I think yes, I think no, I think kind of maybe, but not really so much, maybe on Tuesdays only. And then their answers go to another jury. And that other jury gets the inputs and also what the first jury said. So they get to then have all of that information that then goes to me, and I get the final say as the purple dot. Where each one of these hidden layers has a bias, just like a jury, each juror on the jury will have their own way of thinking. A neural network is the same way. Where after the bias is added, we add what's called a scaling factor to turn it into our 0 to 1, so our yes or our no, and then our -1 to 1, our neutral, strongly agree, strongly disagree kind of scale. Where after the output is given, the bias changes based on how close we were to the answer. So what I'll do is, as the purple dot, I say, all right, I have talked with my jury and we believe the answer is 200. What if the answer was 500? All right, we're pretty far off. So I'm going to go back to the jury and tell them that, hey, we were not even close to the correct answer. Well, why don't you think slightly different? Why don't you think a lot different? Why don't you just leave? We'll find a replacement. So you can do this process of what's called back propagation. It's going back to your jury and telling them, hey, you need to step it up. We got the answer really wrong. Or, hey, you guys got it very, very close. Good job. Keep doing what you're doing. So it will use the information and go backwards and teach itself how to guess better. So a way that I want to use this as an example is this question. How many jelly beans are there in a jar? I think all of us have seen this question at one point or another, whether we were the one asking it or we were the one trying to guess. So my goal here is I want to be able to use a group of people, so a jury of 4 people, to correctly guess the amount of jelly beans inside any jar, not just the one that you see here, any jar. So what is my inputs? What are those green dots that everyone gets? Well, every person is shown 2 things. They're shown a picture of a jar like this, and then they're told the size. How big is it? Is it this big? Or is it this big? Different sizes matter. So everyone gets told that. But there's 2 people, pobrecitos, that don't get everything. One person's only given a picture, and then one person's only given the jar. Or sorry, is only given the size of the jar. So just like our example before, this bottom person only gets this one piece of information. This top person only gets this one piece of information. Okay, so what we do is everyone takes that information and uses their own bias, which is how that person thinks, and they guess. So after they guess, we then collect all of their different guesses, and I get to say, you know what? Meli, she knows what she's talking about. She has gotten the answer correct before. I know that she is very, very smart when it comes to jars that are very tall. Maybe not so much for the ones that are un poco gordito, but she's very good at guessing the ones that are very tall and narrow. So I'm going to listen to her. I'm going to trust her and maybe say I'm going to trust Lupe a little bit. I'm going to take some of what Lupe is telling me. So I'm going to go somewhere between what Meli is saying and what Lupe is saying. But we have all of these different people giving me the answers, not just the two people, not just Meli and Lupe. We also have everyone else. So I collect everyone's answers, choose which ones I think are the most important, and then I give my guess. Like I said before, some of these nodes will be better for certain information. Some people are going to be very good at guessing tall jars, but not wide ones. Some people are going to be very good at guessing ones with big jelly beans. Others are going to be better at guessing the little ones. But over time, we learn who to listen to and how to get the correct answer. So again, we have our pieces of information that we give to the group. The group thinks, each person thinks slightly differently, and then they give me their answers. And then I get to decide where my answer is. It doesn't have to be one of the options they gave me. I get to have my own answer to figure out what I think is really happening. Because I think it would be fun, and because I just got to use it as an example, here is a jar of jelly beans. This jar is 2.5 pounds, so it is very, very large. How many jelly beans are in this jar? Any guesses? Bet you all weren't ready for audience participation today. All right, we got 600, we got 500, we've got 1,000, 500, 1,500, two 1,500s, 1,000,000 jelly beans. 1,100, 1,000, 1,650. So we see already how different all of the answers are. And that's the fun of it, is I get to take all of these different answers and then I get to decide. Some of you may have the right answer. Some of you may be very close. Some of you may be very far. For anyone that was curious, and for all of those playing at home, the correct answer to this question was 1,088 jelly beans. So in this, there are 1,088 jelly beans. So now you know what it looks like. You know what 1,088 jelly beans looks like in a big jar. So then if I gave you this jar, suddenly you have some information. You know that, okay, this one looks like 1,088. This one is 1,088. So the next time you see a jar, you know right away, okay, this one was this big, this one is this big. Okay, let me think, make it a little bit smaller. So you get information. And that is the fun of it, is you guess, you learn what the right answer is. I tell you, okay, you were a little bit high. You get to figure out why or where you went wrong. And then next time, you know a little bit more. You have a little bit more knowledge. Machine learning does this. Most machine learning systems, any that are worth their salt or any that are really worth something, will continue doing this. They will constantly be taking new information and using it to figure out what the answer is. They will get how close to the correct answer they were. So for example, let's see who was very, very close. Adelita guessed 1,100. So she's probably not going to change much with how she thought. Someone like Andrew guessed 1,000,000. Okay, that may be a little bit over. so he may change how he thinks. So we do backpropagation, so the next time we see a jar of jelly beans, we now know that we can get that answer right. Okay, we've talked about a lot of information today, and hopefully some of it has made sense. Some of it may be difficult, but all of it is important, because the ultimate reason that I'm going over all of this, or the answer to why should I care, is simple. I want you to know, because now you know what it looks like, what machine learning looks like. It's not this amazing thing that exists somewhere in the internet cloud. It's math. It is a process of guess and check. But because of that, because it's always a guess, machine learning is not some magic machine that will give you the correct answer 100% of the time. Autopilot in your car or cruise control in your car is not perfect. It is only as good as what it learned from. Most machine learning is only as good as the information it learned from. We could teach a machine how to think, but it's only as good as the way that we told it. Now, simple forms of machine learning exist, like that classification and regression tree that I showed you before. And it makes understanding how the computer thinks very, very easy. And it makes it visual, where I can look at this and I can follow its thought process. But then there's also more complex systems, such as neural networks, where we have hidden layers, this magic curtain that information goes in and an answer comes out. I can tell you the people on the jury, I can tell you who is behind the curtain, but I can't tell you how they think. All I know is that they think well, that they get the answers right. But this is only the beginning, because everything I've shared with you right now are networks that think very straightforward. They think like the human brain. They try and be the human brain. That's why it's called artificial intelligence. It's supposed to mimic how we think, the process of learning. But it has one thing that's missing. What about memory? What about the ability to remember short term? To know that, hey, yesterday what I had for dinner is a lot more important than what I had for dinner 2 weeks ago, if I'm answering the question, what do I want for dinner tonight? So that's where I leave this conversation today, that there are more advanced types of learning out there. Mainly, there's a type of neural network called LSTM, long short-term memory, where it's a neural network like we looked at before, like this, but it learns from itself. So instead of just having the inputs be the size of the jar and a picture of the jar, another input would be what the correct answer was last time. So that what came before is not just training, it's information. So let's talk a little bit now. Let's talk about where you would see this. Let's talk about how you use it in the real world, or how it's used in the real world. And let's talk about how we're using it here at Sectors Made Simple. The first thing is our machine learning, especially our classification trees, tries to do one thing. It tries to figure out between these options, between chocolate, vanilla, or strawberry, what the option is. So there are forms of this that exist in the world. One very common form of it is if you wanted to go look at what the best sector is. It would be The first thing I want to look at is I want any sectors that have a sector BPI, or sorry, not a sector BPI, a sector momentum of 2 weeks of 2 or more. That is the first thing. That's the first step. If the answer to that is yes, it then says, does it have a positive trend of 5 or more? Yes. Then that would say buy. That is a simple form of a decision tree. It says, is it higher than this number? Yes or no? Okay. If it's higher than that number, is it also higher than this number? Yes or no? And we could use this. This is, funny enough, how our strategies were created. We had these systems, we had these trees that we learned, and we found the ones that could guess the correct sector the most number of times, could get the answer right the most. But then there's other ones that exist. There's this idea of micro trading or microtransactions, where investors have created machine learning that is able to figure out, because it's hard to say what stock is going to go up tomorrow. It's so random. There's too much information to think about. But instead of trying to predict what stock is going to go up tomorrow, what if I just looked at the market and said, what stock is going to go up in the next second? That is where microtransaction or micro trading comes in. It is banks, it is big industries that spend millions and millions of dollars training a machine to figure out what stock is going to go up in the next second, so that they can buy it, have it for that next second, and then sell it 1 second later. This is an exaggeration. Of course, it doesn't happen in the course of 1 second. That's ridiculous. It happens in thousandths of a second. It happens in milliseconds. It happens faster than you can react to anything. So much so that real estate getting closer and closer to Wall Street is increasingly more expensive, not for offices, but literally so companies can put a computer as close to the New York Stock Exchange as they can, so that they get that information milliseconds faster than their competitor. Because Chase Bank has their machine, but so does H&R Block. So does TD Ameritrade. All of them have these machines that predict what stock is about to go up. So it's a race to see who can get that information first. Because the first person is going to make the most profit, then a little bit less and a little bit less and a little bit less. So it's not just a matter of how often can you get it correct, it's how fast can you get the correct answer, but how fast can you get those inputs. And that's the crazy part of all of this, is machine learning trades the vast majority of stocks on the New York Stock Exchange. They are the reason that stocks go up and down, is that a machine bought and sold stocks without a human having to say anything, because the machine thought that there was a probability, a high probability, that they would make money on that trade. And that's the $1 million question. It's not a $1 million question, it's the $1 million answer to the question. What stock is going to go up? Alex is asking a question. We get that information by patterns from years. Yeah, so what would happen is we would say, here is the last 100 years of stocks, broken down by the second. So literally 1 second of 1 hour of one trading day, of one trading year, 100 years. throw all of that into a machine learning system to figure out what matters. But remember, as I said before, it can hit a dead end. And that's the biggest risk, is it will hit dead ends. And you don't know if it's a dead end or the correct answer, or the best answer, let's say. So that is where it comes down to the information you get out of it is only as good as the information you put in. I wanted to do some experimenting myself. Nate and I started off all of this before we had sectors made simple. We started off by testing. Can we use things in the market, information that we can collect from the market, to predict what stocks will go up and down? We could, but it wasn't very good. Because if it was so easy that we could do it in our bedrooms using our bedroom computers, Schwab can do it with their supercomputer and a couple $1 million. So we realized that the reason that we weren't beating them wasn't because they had more money. It's because they had better data. They had better training. They had better teachers. So we learned. We as humans learned. We learned what information matters. What data is important. Because the stock price is going up and down in the middle of the day, that's important, yes. But how they change relative to another sector is way more important. So we created the matrix. Because the matrix is great information that we can give to a human. And the human can find the correct answers. So now we've learned as humans how to use the information on the matrix to trade. So now, as matrix creators, we go back. And our current goal is to go back and see if we can create a network. Not one like this, not a simple tree, but figure out that answer to the jelly bean question for stocks. What is the leading sector? How long will it be the leading sector? And how confident am I that it will be the leading sector? That is the next goal, is for us to be able to create a machine learning algorithm, that will be able to predict what sectors will be leaders. But as I said at the very beginning of all of this, machine learning is a huge marketing term that you will hear people use day in and day out, and I will not bore you with it, because I want you to always know, trust but verify, because a machine is only as good as the people who created it and the information it's given. You are a human that can take way more information and process it in a way that you can understand. So trust your machine. Trust how you think, and always verify. Because no machine will give you the right answer, but if we take a lot of machines and put them all together, then maybe we'll start getting somewhere. And that is why investing is more fun with friends. Sectors are made simpler when we compare them against each other. And why all of this is why we're doing it. Because it's fun, because more ideas give better insights, and because investing can be made simpler with more information. Thank you all so much for joining us today. I know it was a little bit more of a crazy topic, but I hope everyone got to learn a little bit more, where the next time you see the words machine learning, you now know what it looks like. And you now know the answer to how many jelly beans are in a 2.5-pound bag of jelly beans. Thank you all so much for joining us today. Hopefully everyone has a great weekend. Happy Halloween, and I'll see you all next week. Thank you all so much. Bye.